Hello to all. Today we will start the first unit according to this CBSE syllabus, the electrical charge and charges and fields. Let us start with the introduction of electric charges. First of all, let's see what is electrostatic. Electrostatic, the branch of physics which deals with electric charges at rest, is called electrostatics. And what is electric charges? Electric charges are the fundamental physical quantity due to which electrical and other related effects are produced in the matter. Electric charges are of two kinds, positive or negative and negative. The electric field lines for a positive charge, that is when Q is greater than 0, the electric field lines are represented by the outward arrows. And when there is a negative charge, that is the Q is less than 0, then electric field lines can be represented by the inward arrows. Electric charge is a scalar quantity, means it has only magnitude. And the dimensional formula is AT, ampere time. How is it derived? As we know that the current is charge per time. Current is the ratio of charge by time, and charge is the product of current into time. So current is in ampere and time is in time is represented by the capital T. The examples of electrostatic charges, when you have seen that when you remove a polyester shirt, then you have seen the sparks, and that is the cause of electrostatic charges. Another is example. Let us consider this. This is a rubber rod. When you rub this rubber rod with fur, then the fur, that the charges will transfer from the fur to this rubber. And as we know, due to gain of electrons, this rubber rod is electrified by negative charge. And when if we come closer and another rubber rod to this rubber rod, then the repulsion between these two rubber rods is found. When this rubber rod is make a contact with a glass rod, and this glass rod is previously rubbed with a silk cloth, and the silk cloth gained electrons and become negatively charged, and this glass rod, due to removal of electrons, it becomes positively charged. So when this glass rods came near this rubber rod, there occurs an attraction between these two rods. So we can conclude that the like charges repel each others and the opposite charges attract each others. All these materials are tabulated in this form, as this can come in the form of objective type questions, like when glass rod is rubbed with a silk cloth, which one will be negatively charged and which one will be positively charged. So glass rod will be positively charged and silk cloth will be negatively charged. Similarly, when fur or wool is rubbed with rubber, then rubber is negatively charged and wool becomes positively charged due to removal of electrons. And next example is dry hair and plastic comb. Plastic comb becomes a negatively charged due to the gain of electrons, and dry hairs become positively charged due to removal of electrons. So this example we have discussed, the polyester shirt removed from human body gives sparks in the dark. Now here is a practice question for you. When a glass rod rubbed with silk cloth acquires a charge of 1.6 into 10 to the power minus 19 coulomb, what is the charge on the silk? So according to conservation of electric charge, there is a transfer of electrons from glass rod to silk. According to this previous table, glass rod become positively charged and silk cloth become negatively charged due to gain of electrons. So due to conservation of charges, both both will have this have charge equal to plus E, and this acquires the charge of minus E due to gain of electrons. So the answer to this question is, when a glass rod is rubbed with silk cloth, it loses one electron, hence acquires plus E charge, which is transferred to the silk cloth to conserve the charge. So the charge on the silk is equal to the charge on the electron, that is minus E. Okay, here is another question. When this glass rod is rubbed with this silk cloth, there is a transfer of charge between both these substances. Whether there is a transfer of mass also. So there is a similar type question, that plastic piece is rubbed with wool, as a result of which it requires negative charge. Is there any exchange of mass between wool and plastic? So yes, the answer is yes. There is a transfer of mass, and how much amount? The the amount of mass which has been transferred from plastic. In this question, plastic piece is rubbed with wool. So which one will be negative, or and which one is positive? According to this table, we can see when a rubber is rubbed with the wool, then wool become positively charged and rubber become negatively charged. So due to gain of electrons, its mass will be higher than this wool, and as this wool loses the electrons, so its mass will be lesser, and the this rubber rod, due to gain of electrons, its mass will be increased after this rubbing. So next is, repulsion is the surest test for electrification. Or this kind of question, this is a conceptual type question, and just for understanding, can we consider the repulsion is the surest test for electrification rather than attraction? Here we can understand this concept by this diagram. The attraction occurred when two bodies will be either charged, and attraction also occurs when one of the body is charged and other body is not charged. So attraction is also occurs if one of the body is charged, but in case of repulsion occurs when both the bodies will be charged. If one body is charged and another body have no charge, then there will be no repulsion. And in case of attraction can be occurred between one of if one of the body is charged and another body is not charged. So repulsion is the surest test for electrification when we because we will in case of repulsion, we can consider that both the bodies will be charged, and electrification occurs when both the bodies have some charge. So you can give answers in your wording. If you understand this concept, you can write it in your own words. Now, next topic is conservation of charges. Firstly, in introduction part, you have uh, understand the concept of electric charges. The next is conservation of charge. What is conservation of charge? Uh, let's start with the quantization of charge. According to quantization of charge, the existence of charge occurs in discrete packets rather than in continuous amount is known as quantization of electric charge. Means if you consider if you consider this is there is an electrical body, an object having some charge, and the amount of charge that this body uh, attain is equal to the integral multiple of elementary charge. Q is equal to Ne. According to this quantization of charge, you can calculate the quantity of charge on any electrified body. You can understand this concept by this numerical. Suppose there is a metallic body, and the question is you have to find the amount of electrons ejected from this surface. If the charge on this body has given equal to 10 to the power minus 9 Coulomb. If this is given to you, and it has been asked that what is the number of electrons that has to be ejected from this surface, you have to calculate. Then you can calculate by this formula that Q is equal to Ne, and to calculate N, that is the amount of electrons ejected from this surface, you will divide this Q by this elementary charge. That is what is the 1 electron charge? This is 1.6 into 10 to the power minus 19 Coulomb. Now, conservation of charges. Before going to this topic, conservation of charges, let us attempt this numerical. A polythene piece is rubbed with wool and it has been found to acquire a negative charge of 3 into 10 to the power minus 7 Coulomb. How many electrons have transferred from wool to polythene pieces? So this is again the same question. You have to find the N. N is equal to Q by E. So N is equal to Q by E, and Q is given to you 3 into 10 to the power minus 7, and E is 1.6 into 10 to the power minus 19, and this will be in negatives. Why? Because this is this polythene piece will acquire negative charge of this. So you can calculate the number of electron transferred according to this first part as N is equal to Q by E. Next is the second part is there a transfer of mass from wool to polythene? If yes, how much? So the answer is yes. If charge will be transferred from the from this polythene piece to from this wool to this polythene piece, then there will definitely the transfer of mass. And if you want to calculate how much mass transfer from this wool to polythene, then you can calculate like as you have calculated this N, the number of electrons on the transfer to this polythene piece. This is 1.8 into 10 to the power 12, and mass of 1 electron is 9.1 into 10 to the power minus 31. You have to remember this. Sometimes this is given in exams, but this is a very general term, so you have at least you have learned the one electron charge 1.6 into 10 raised to power minus 19, and the charge of and the mass of one electron, that is 9.1 into 10 raised to power minus 31. So you can calculate the mass transferred also, which is product of number of electrons on this polythene piece into mass of one electron. How this is the next numerical. How many electronic charge form 1 coulomb of charge? So for 1 coulomb of charge, that is one is given, the Q is given. You have to calculate the N. How many electrons form 1 coulomb of charge? In simple words, how many electronic charge means how many electrons form 1 coulomb of charge. So when you divide this 1 coulomb with one elementary charge 1.6 into 10 raised to power minus 19, you'll get this number. Now let's comes to conservation of electric charge. So according to this law, the total electric charge in an isolated system remains constant. That is, the charge can neither be created nor be destroyed. Like you have two things. There are you have read number of examples. In the last numerical, you have seen it is a polythene piece and this is wool. The electrons transferred from this wool to this polythene piece. So this will acquire the plus E charge and this will acquire the minus. This polythene piece has minus E charge. So charge is transferred from one body to another. But charge can neither be created nor be destroyed. There is no destruction of charge. There is no creation of charge. Charge is transferred from one body to another. And the total net charge in an isolated system remains constant. When this plus E and minus E take this algebraic sum, then net charge will remain always constant. You can give any of the examples the mentioned above in table, like a glass rod rubbed with the silk cloth. What will happen? The algebraic sum of charges after rubbing continues to be 0. The total charge is conserved. So in pair production, annihilation matter, you can understand this. Now, according to this syllabus, next topic is Coulomb's law, force between 2 point charges. Coulomb's law can be represented by scalar form as well as in vector form. So according to scalar form, the force, the magnitude of attractive or repulsive forces between two charges at rest is directly proportional to the product of these charges and inversely proportional to the square of the distance between them. Means if you have these, there is two charges separated by a certain distance r. This is q1 and this is q2. Then the force, Coulomb's force between these two charges will be directly proportional. What is the meaning of directly proportional? Means when this product increases, the amount of this product increases, then force between them, these two charges will increase. And F is inversely proportional to the square of the distance between them. Means when this square increases, the force between these two charges decreases. This is the inverse relation between F and R square. Okay, is this clear? So F is equal to uh, F is directly proportional to Q1 into Q2 by R square. When you remove the direct proportionality constant sign to equate the equation, then you will put this constant of proportionality. This is called the Coulomb's constant, and its value is 1 by 4 pi epsilon naught. And what is epsilon naught? Epsilon naught is the absolute permittivity of free space. What is absolute permittivity of free space? This is the capability of vacuum to permit electric field. So if you want to write the Coulomb's forces in vector form, this is Q1 and this is Q2 separated by a distance r, and these are the position vector for Q1, that is r1, and this is the r2 vector for position vector for Q2. So Coulomb's force acting on Q2 due to Q1, Coulomb's force acting on this Q2 due to this Q1 is F21, and F21 will be F by 4 pi epsilon naught Q1 Q2 divided by the square of the distance between them. What is this distance? AB, the magnitude of AB square. And as we are writing this Coulomb's force expression in vector form, so here we will put a unit vector with this expression of scalar. This is the Coulomb's expression, Coulomb force expression in scalar form. We will additionally write a unit vector R12 to represent this Coulomb's force in vector form. So to calculate this AB, this distance AB, according to triangular law of vectors addition, OA plus AB is equal to OB. See, OA plus AB is equal to OB. In the previous class, in vectors chapter, you have seen that if there is a vector A and here is a vector B, then their resultant will be like this, and this is the sum of these two vectors. This is triangular law of vectors addition. OA plus AB is equal to OA plus AB is equal to OB, and now you have to calculate AB, and OA and OB is already given. OA and OB is given, so you have to calculate AB only, and AB will be OB minus OA, and here is OA is equal to R2 and OA is R1. OA is R1 and OB is R2. So R2 minus R1, here is a representation. We have taken this as R12. AB is taken as R12. Means this is the charge from Q1 to Q2, and this is the AB distance like R12. And this is the force on Q2 charge due to Q1. So put R12 vector in place of AB vector in this first equation. Similarly, Coulomb's force acting on Q1 due to Q2 charges, all will remain same. You will write R21 unit vector in place of R12, and now there is a for when you will calculate the force acting on Q1 due to Q2, you will consider BA distance. Now BA vector, to calculate the BA vector, OB plus BA is equal to OA. OB plus BA. Now here is the direction of BA is toward this OB. Here is OB, BA, and here is the resultant OA. So this is R2 and this is AB, BA. You have to calculate this BA and this is R1 given. Means this, in this case, resultant is given and you have to calculate this AB. So this is R2. So AB, what will be AB? Sorry, BA, OB plus BA is equal to OA, and BA will be OA minus OB. And this is R1 minus R2 and this is R21. Put in 3 and you will get this. And from second and fourth, this is almost same, but there is only the difference of the magnitude is same, but the direction is different. This is 1 by 4 pi epsilon naught q1 q2 r square and r vector. For r1 to this is r21 and this is for r21 this is r12 from A to B, and this is the direction from B to A. So from second and fourth, it has been cleared that the force between these two charges will be equal and opposite. And again, this is the Newton's law. According to Newton's third law, action and reactions are equal and opposite. So Coulomb's law can tell, we can verify the Newton's third law by this Coulomb's law. And what is this? If you want to calculate the Coulomb's constant, as this value is required to solve many numericals, so you must know the value of this. And 1 by 4 pi epsilon naught, how you calculate 4? You can write pi as 3.14 or 22 by 7 also. You can use this also. So here I have taken 3.14 and epsilon naught. The absolute permittivity of free space. What is absolute permittivity of free space? This is the capability of vacuum to permit electric field. So its value is 8.854 into 10 raised to power minus 12 Coulomb square per Newton per meter square. So after solving this value, we will get the Coulomb's constant as 9 into 10 raised to power 9 Newton meter square per Coulomb square. Now next is dielectric constant. This is a very important for solving many numericals when you have, because this Coulomb's expression that you have solved in scalar form and vector form, this is when these two charges are placed in vacuum or air or vacuum. In that case, you will simply calculate the Coulomb force. But if these charges are immersed in some medium like water or anything else, then what will be the resultant Coulomb's force? That will depends upon the dielectric constant of the medium. For instance, K is equal to 80 for water. It is K is equal to 80. So if you want to calculate the Coulomb's force between these two charges when these Q1 and Q2 are immersed in water, then firstly you will calculate it in air, and then F in medium will be F in vacuum divided by dielectric constant. So, and if you want to calculate this, if you want to define this K, then K will be F by Fm. So this is the ratio of Coulomb's force in air by Coulomb's force in medium. Dielectric constant is defined as the ratio of Coulomb's force between 2-point charges placed in air to the Coulomb's force between the same point charges in medium at the same distance from each other. K is equal to F by Fm. Here is the numerical to understand this dielectric constant. Two extremely small charged copper spheres have their cells separated by a distance of 50 centimeters in vacuum. There are two charges, copper charges. There are two copper spheres separated by 50 centimeter. What is the mutual force of electrostatic repulsion? As these are of same charge plus Q, and this is also plus Q. So there will be the repulsion of between these two charges. So you have to calculate F between these two charges, and the charge is given. Both have the same charge of 6.5 into 10 to the power minus 7. Q1 is equal to Q2 is equal to this, and R is 50 centimeter is given. So you can easily calculate this F by solving this formula and take 1 by 4 pi epsilon naught as 9 into 10 to the power 9. Next is, what is the force of repulsion if the charge on each sphere is doubled and their separation is half? So easy. What will you have to do? The charge is doubled, take the product of 2 into the amount of charge, and the distance between these two charges is half, divided by 2. Then again calculate this value. Here this is the important part, that to understand dielectric constant. The two spheres are placed in water. If these two spheres are placed in water, then what is the force of repulsion? And the electric constant of water is kT. If these two charges is placed in water, then the force in medium will be force in vacuum divided by the electric constant of the medium. This is again the same kind of question for your revision. Forces between multiple charges, principle of superposition. The next topic is forces between multiple charges, superposition principle. What is superposition? Superposition means when there are multiple charges and you have to calculate, like in Coulomb's force, you have considered two charges and calculate the force between these two charges. If this is Q1 and this is Q2. Suppose there are multiple charges like Q1, Q2, this is Q1, this is distance from represented by this unit vector, position vector R1. There are Q1, Q2, Q3, Qn. There are n number of electrons. So you have to calculate the charge, the net charge on this Q naught. If you have to calculate the net electric force on this Q naught charge by all these Q1, Q2, Q3, Qn, then how will you calculate? You will take the algebraic sum of all these charges. Firstly, you will calculate the Coulomb's force between Q1 and Q naught. Then you will calculate the force between Q naught and Q2. Then Q naught and Q3, and similarly up to Qn. Then you will take the sum of F F01 plus F02. That's the force between Q0 and Q2. Similarly, F03, so on F0n. So, according to the principle of superposition, the total force acting on a given charge due to the number of charges around it is the vector sum of individual forces acting on that charge due to all the charges. So, according to superposition principle, F will be this algebraic sum of all these charges. So, if for Q, the force between Q0 due to Q1, this will be like this in vector form. Okay, uh, if you want to expand this R unit vector, you must know this unit vector can be written as the ratio of this vector divided by the magnitude of this vector. So R10 unit vector can be further rewritten as R naught minus R1 divided by R naught minus R1's magnitude. Similarly, F02 and so F03, and take the algebraic sum of all these equations and take sigma for this addition from 1 to n. Here is a numerical for your practice. This is the same. You have to calculate the distance between these two charges. Charges are given, force is given, and you have to calculate the R by this Coulomb's force expression. Similarly, this is again for practice. Force acting on two charges in dry air. If the metallic medium is added between the charges, what will be the new charge? Okay. If the metallic mediums, for if there is a two charge, if the metallic medium added between these two charges, then the force will be zero. How? Epsilon naught, epsilon is equal to F will be actually, if you want to understand this epsilon, this is actually epsilon naught and relative permittivity. And this relative permittivity is equal to dielectric constant. And epsilon will be, for metal, it is infinity. And if you, according to Coulomb's force expression, there is 1 by 4 pi epsilon naught q1 q2 by r square, means epsilon will be in denominator and epsilon for metals is infinity. So 1 by infinity is 0. So F will be 0 if a dielectric, if a metallic medium is added between these charges. What will be the new force? The new force will become 0. This is again for practice questions. Okay. Two identical metallic spheres of exactly equal masses are taken. There are two metallic spheres of equal masses. One is given positive charge and other is negatively charged by friction. Like means this charge is rubbed with this, and due to friction there is a transfer of charges between these two objects. first will become plus charge plus q, and this will become minus q charge. Are their masses after charging equal? This is again a similar question. You have it has been discussed in the very starting of this chapter, when we have discussed the electrical charges. So the answer is yes, there is a exchange of masses between these two bodies. The charge of this negatively charged body will be will be increased. The mass of the positively charged bodies decreases and that of negatively charged bodies increases. When one of the two identical metallic spheres of charge, positive and negative, their masses after charging will not be equal. Masses will not be equal. The body which gains electrons have more mass than the body which loses the electrons. Here is another numerical. What does this signify in electrostatic? According to this, Q1 is Q1 plus Q2 is equal to 0. What does this signifies? Q1 is equal to minus Q2. Means these two charges are equal and opposite. The next question is, what is the basic cause of quantization of charge? During the charging process, only integral number of electrons is transferred from one body to the another. That is, you can count according to quantization of charge, you can count the number of charges transferred from one body to another. So the amount of amount of electrons transferred from one body to another is the integral number of electrons transferred from this body to another body. Therefore, charge possessed by a body is always an integral multiple of this elementary charge. This is the numerical for superposition of electrical force charges. 4-point charges are located at the corner of square ABCD. At A, 2 microcoulomb, B minus 5 microcoulomb, this is 2 microcoulomb, this 5 minus 5. What is the force on charge of 1 microcoulomb? And these charges are located at the corners of ABCD of side 10 centimeter. This is 10 centimeter. From deep, this is a square, also, so its side is 10 centimeter. What is the force on charge 1 microcoulomb placed at the center of the square? Here is a charge 1 microcoulomb. What is the net charge, net force acting on this 1 microcoulomb? ABCD is a square of 10 centimeter side. The charge of 1 microcoulomb is placed at the center. So QA and QB are equal and opposite. If you calculate the force FA, that is the force between this 1 microcoulomb and 2 microcoulomb, that the force will be opposite, because these are two charges are of a same kind, positive sign. So there is a repulsion between these two charges. FA will be along this side and FC will be FA along this side, and for this charge, the force between 2 microcoulomb and this one, this is again FC will be along this side. So QA, this QA charge and QC charge are equal. As you can see, 2 microcoulomb, QC is also 2 microcoulomb. The charges of 1 microcoulomb, this experiences equal and opposite forces due to charges QA and QC. This FA force is in toward this direction, toward QC, and this FC force act along this QA charge. So this charge, 1 microcoulomb, experiences an equal and opposite force due to this QA and QC. Similarly, the charge of 1 microcoulomb experiences equal and opposite forces FB and FD due to the charges QB and QD. QD and QB has a net force on the charge of 1 microcoulomb due to the given arrangement of charges is 0. This is again a numerical for your practice, that force of attraction between 2 point charges in a medium is F. What is the distance apart should these be kept in the same medium so that the force between them becomes F by 3. When this F become F by 3, what will be the distance between these two charges? This is the question. So you have to simply calculate the X, and this will be the X is equal to under 3D. Again, the Coulomb force between these between two alpha particles separated by a distance this much. Yeah, you will use, means you have to learn this formula, 1 by 4 pi epsilon naught into Q1 into Q2 by R square. Here Q1 and Q2 is given, R, the distance between these two charges is given, so you can easily calculate the force. So I think this is enough for today. The next class will cover the continuous charge distribution and electric field due to point charges, and electric field lines. This is for next class. This is the question paper of 2020 according to CBSE, and electrostatic force and the question from this unit, that is electrostatic force. There are 2-3 questions. Okay, from this question, this is clear that you have been asked indirectly, like if unit you have given the unit of any physical quantity, and you have to given the answer what will be the physical quantity whose unit is like this. So you have to learn all the units of all physical quantities, like Coulomb's force and everything. Coulomb's, what is the unit for Coulomb's force, potential, electric field. So we will see this question paper in next class. Okay, thank you.